Ashok Leyland's BS6 Sales Training. Welcome to the module on BS6 Sales Training. In this module, you will learn about BS6 emissions, Ashok Leyland strategy, technology, and sales case studies. Module objective. By the end of this module, you will be able to outline emissions and timeline in India, utilize mid-NOx strategy against competition, illustrate key telltales in BS6 vehicles, demonstrate Ashok Leyland's BS6 technology is better than the competition, utilize Ashok Leyland's BS6 technology confidently to sell more and sell effectively. Sell more and sell effectively. Do you know how Ashok Leyland's BS6 technology is better than competition and helps you sell more? We will understand the benefits one by one in detail. Proven IEGR engine design retained with few add-ons for better engine performance compared to the competition. Mid-NOx strategy ensuring better NOx conversion efficiency, hence better engine and exhaust after-treatment system durability leading to the better cost of ownership against the competition. Lower AdBlue consumption, therefore lower cost of operation per ton kilometer against the competition. Compact design, hence incremental payload and low maintenance compared to the competition. Unique HC doser used for DPF regeneration is a better option than late post-injection used by the competition, ensuring longer oil change interval and hence lower maintenance cost. Longer active regeneration interval compared to the competition, thus economical regeneration and longer DPF life. Longer DPF ash cleaning interval compared to competition by design, hence lower maintenance cost. Ashok Leyland's unique air-assisted AdBlue dosing for higher efficiency and lower risk of urea deposition in exhaust system than the competition. Therefore, better exhaust after-treatment system performance. Understanding emissions and timeline in India. Do you know what causes emissions? Let us now understand the causes of emission. Automotive emissions in urban areas, industrial activities leading greenhouse gases. Hence, air pollution around us is increasing day by day, leading to various health issues which must be taken into consideration for reduction of emissions. BS6 emission journey. What are the norms to control automotive emissions? The Bharat stage are standards instituted by the government to regulate the emission of air pollutants from motor vehicles. In 1999, BS1 was introduced in NCR Delhi region on cars and LCV to control pollution. By 2000, BS1 presents across nation pan-India. In 2001, BS2 was implemented in all metros. By 2003, BS2 was implemented in NCR and 11 cities. By 2005, BS2 was implemented in Pan-India and BS3 was implemented in NCR and 11 cities. In 2010, BS4 was implemented in NCR and 13 cities and by then BS3 Pan-India. In 2013, On-Board Diagnostics OBD all BS4. In 2014, BS4 in NCR, Delhi for cars and LCV. In 2015, BS4 was implemented in 30 plus cities and North India. In 2016, BS4 was implemented in South India. In 2017, BS4 Pan-India. By 2020, BS6 will be implemented Pan-India. The emission legislation implementation till BS4 has been brought in a phased-wise manner, 7 to 10 years. However, for BS6, the implementation is within 3 years span. BS6 emission norms. Significant constituents of automobile emissions are oxides of nitrogen, NOx, unburnt, burnt hydrocarbon, HC, carbon monoxide, CO, particulate matter, PM. As you can see from the graph, the percentage reduction of NOx is 90% from BS4 to BS6. HC is 70% from BS4 to BS6. And PM is 50% from BS4 to BS6. Here we can see the BS6 regulations are getting strict and stringent. Hence, a better strategy and technology is required to control the emissions. Emission generation. Now, let us learn what causes automotive emissions. NOx is formed due to higher temperature and oxygen availability inside the combustion chamber. PM is formed due to left out carbon particles surrounded by oil, sulfur, ash. HC, unburnt hydrocarbons, and CO, carbon monoxide, are formed due to improper combustion inside the combustion chamber. CO is formed due to incomplete combustion and slow oxidation process. Non-uniform combustion as a result of multiple events occurring simultaneously. AL mid-NOx strategy against competition. Mid-NOx strategy. The NOx control strategy can vary from massive EGR to massive SCR usage. As you can see from the graph, if a high amount of exhaust gases are recirculated back to the engine, as in case of massive EGR strategy, the particulate matter PM from the engine is very high. On the other side, in case of massive SCR, which is only SCR, the NOx emissions from the engine are extremely high. A mid-knock strategy is a balanced approach and can be achieved by using IEGR plus SCR plus DPF, which also, as understood, already improves the system durability, longevity and efficiency. Ashok Leyland's mid-NOx gives better TCO, less AdBlue consumption, improved exhaust after-treatment system, durability, compact exhaust after-treatment system, design and cost effectiveness. Emission control. Emission control in AL vehicles happens in two stages. In cylinder within the engine. Exhaust after treatment system. Let us understand in-cylinder emission control in detail. Sulfur control in BS6 fuel. The sulfur content in the diesel also needs to be controlled as it contributes to particulate matter and can lead to deterioration of noble metal coatings in EATs due to sulfur poisoning. Sulfur poisoning happens due to sulfuric acid, which leads to corrosion of metals as well. The BS6 fuel can be added in BS3 and 4 vehicles and nothing will happen to the engine. What will happen if you put BS4 fuel in BS6 engine or mix both? It's very harmful to the EATs system as a higher quantity of sulfur will increase the PM and lead to the formation of sulfuric acid, and these in turn will lead to faster choking of DPF and sulfur poisoning of noble metals. In-cylinder emission control. Let us now understand in-cylinder emission control in detail. Proven IEGR engine technology. Proven IEGR engine taken forward. We will now talk about what we have done in BS4 to achieve the norms. To reduce the majority of the emissions within the cylinder, two major parameters need to be controlled. Uniform nature of air-fuel mixture, peak firing temperature. The four major parameters contributing to emission reduction inside the combustion chamber are air management, IEGR, fuel management, oil control. Air management. Air management within cylinder done in two ways: swirl, which improves homogeneity; quantity improves the performance. New design of combustion bowl and inlet port helps in better swirling and mixing of air inside the combustion chamber. Hence, ensures more uniform air-fuel mixture for better combustion efficiency. Increase in the inlet ports and the turbocharger with wastegate and intercooler helps in increasing the amount of input quantity of air into the intake manifold, hence better performance of the engine. Helps in controlling NOx, PM, HC and CO. IEGR. Exhaust gas recirculation. IEGR is an emission control system that lowers the amount of nitrogen oxides, NOx, formed during combustion by recirculating cooled exhaust gas back into the cylinder. The exhaust gas from the exhaust flows through the piping and reaches the EGR valve. Based on the engine condition, ECU actuates the EGR valve, according to which the required quantity of exhaust gases will be sent inside the engine. Coolant from the cylinder block enters the EGR cooler. The coolant in the EGR cooler cools the exhaust gas sent through the valve. EGR passes through the pipe and the coolant surrounds the pipe. cooled exhaust gas then reaches the intake manifold. The coolant from the cooler flows through the EGR valve back to the engine coolant outlet port. More cooled air enters the cylinder and thereby reduces the temperature, which lowers the amount of NOx formation. Fuel management. CRS, Common Rail System, helps in controlling CO and HC. Higher operating pressure of common rail results in fine fuel spray, hence better atomization of fuel. Better atomization of the fuel ensures better fuel-air mixture, resulting in better combustion, hence lowers the amount of NOx, CO, HC, PM. Oil control. Honing inside the cylinder liner creates fine crosshatch imperfections on the surface of the cylinder bore. These are essential because it helps the cylinder wall retain oil to assist with piston ring lubrication. Due to this, a very thin layer of oil is formed between the edge of the piston rings and cylinder wall. Thus, it doesn't mix with fuel and hence no formation of PM. Engine oil is a foreign particle. When it takes part in combustion by slipping between the piston rings, it forms particulate matter, PM. Liner honing is a surface machining process which helps in preventing the oil from escaping between the liner and the piston rings during operation, thereby reducing the formation of PM. Oil control helps in controlling PM. The three mentioned ways such as air management, IEGR, fuel management helps to control COHC NOx, whereas PM is controlled through oil control inside the combustion chamber. Engine add-ons from BS4 to BS6. Though the following components are mounted on engine, the same will be part of exhaust after treatment system. Hence, we will be covering the same in detail in exhaust after treatment section. Intake throttle valve, HC dosing system, temperature EGR sensor, NOx sensor. The exhaust brake is only a position change from vehicle to the engine and it is not related to BS6 emission. Only 2 sensors and 3 actuators are added apart from BS4. 2 sensors, temperature EGR sensor, NOx sensor. 3 actuators, intake throttle valve, HC metering unit, HC injection unit. Though the above mentioned sensors and actuators are mounted on the engine, the same will be controlled by exhaust after treatment system. Temperature sensor and NOx sensors. TEGR is a regulatory requirement. NOx sensor is used to measure NOx levels coming out of the engine. Exhaust brake, which was earlier a part of the exhaust pipe, is now moved to the exhaust manifold. Temperature sensor to measure the EGR temperature after cooling, used for measuring EGR cooler efficiency. NOx sensor to measure the NOx level of the exhaust gas, used for optimizing SCR calibration. No changes within the engine, same IEGR technology retained. Sales tips. The above in-cylinder emission control was a part of our successful IEGR BS4 technology, which has sold over 3 lakh plus vehicles. Since a part of the emission is already controlled within the engine cylinder, Our exhaust after treatment system will be simple and compact compared to competitors. Exhaust after treatment system is a new component added at the end of the engine to reduce further the emissions coming out. Competitions majorly relied on managing the emission outside the engine during BS4, and hence will need to now focus on in-cylinder methods and exhaust after treatment system for BS6. Exhaust after treatment system. Emission control in Ashok Leyland vehicle takes place in two stages. First in cylinder, second in the exhaust after treatment system. Exhaust after treatment system components function. This is the schematic diagram of exhaust after treatment system along with its components functioning. Let us go through the components one by one. Intake throttle valve monitors the SCR working temperature. N1 measures the NOx level coming out of the engine. HC doser sprays fuel to facilitate regeneration in DPF. T1 monitors the temperature of gases entering DOC. DOC oxidizes the gases and converts CO and HC to CO2 and H2O, NOx to NO2. T2 senses the temperature of gases entering DPF. DPF. PM gets filtered through physical filtration. Delta P helps in measuring the soot loading in DPF by measuring the difference in P1 and P2 pressure. T3 and T4 both monitor the temperature of gases entering SCR. AdBlue doser sprays AdBlue so that the exhaust gas and the AdBlue solution mix well before entering the SCR. SCR is coated with copper zeolite, leads to catalytic conversion which converts the NOx into N2. ASC contains catalyst copper zeolite and platinum. ASC converts NH3 into N2. T5 measures the temperature of gases coming out of exhaust. N2 measures the NOx level of gases coming out of the exhaust. Exhaust after treatment system working. NOx sensor 1 measures the NOx level coming out of the engine. T1 monitors the temperature of gases entering DOC must be above 200 degrees. In DOC, HC and CO get converted to H2O and CO2. This is an oxidation reaction and heat are generated during this process, exothermic reaction. A minimum of 180 degrees to 200 degrees Celsius is required for the conversion to happen. T2 senses the temperature of gases entering DPF must be above 270 degrees. In DPF, PM is filtered. This is a filter which allows the gas on only one passage and the other end is blocked. Hence, the gas is forced to flow through a wall which filters the carbon content. PM gets filtered through physical filtration in DPF. DPF keeps filtering PM. Thus, soot deposition takes place within the filter. DPF needs to be cleaned frequently to ensure DPF filtration efficiency. Delta P helps in measuring the soot loading in DPF by measuring the difference in P1 and P2 pressure. Regeneration is a process of burning the accumulated soot in DPF filter. Metered quantity of fuel is sent to the HC doser by the metering unit. The doser sprays fuel to facilitate regeneration in DPF. Exhaust after treatment system working. Regeneration. There are three types of regeneration possibilities: passive regeneration, active regeneration, parked or stationary regeneration, and finally removal and cleaning. Passive occurs naturally about 250 degrees on a running vehicle. Active. If operating conditions do not allow passive regeneration, active regeneration takes place. The temperature required and generated for active regeneration is above 500 degrees. Active regeneration is facilitated by spraying additional fuel by HC doser to raise the temperature. Active is assisted by HC dosing system. However, before active regeneration can occur, a warning signal appears for the driver on the display panel. The driver can choose to delay or inhibit the active regeneration for some time, depending on the running conditions. Parked or stationary regeneration. Driver can choose for a parked regeneration when the vehicle is in a stationary condition and at a safe location for regeneration. If the accumulated soot crosses the boundary conditions beyond regeneration possibilities, it may be required to remove the DPF and send it for cleaning. DPF ash cleaning frequency of first cleaning is after 3 lakh kilometers. HC dosing system. The HC dosing system consists of HC doser and HC metering unit. Function of HC doser is to inject fuel for regeneration as and when required. Metered quantity of fuel is sent to the dosing unit where it gets dosed from the injector. During the process, DPF gets clogged with carbon particles and hence it must be regenerated at regular intervals. During active regeneration, HC doser sprays the fuel into the exhaust line. This gets reacted at DOC and liberates more heat. Hence, due to more oxidation, the exhaust temperature increases. HC doser versus post-injection competition. There are two ways available to achieve DPF soot burning: HC doser, post-injection. Post-injection refers to fuel being injected in the cylinder during the exhaust stroke. The fuel then comes out of the engine along with the exhaust. The key advantage of HC doser over post-injection is less HC slip, which leads to less oil dilution. Less oil dilution gives a better oil change period. HC slip refers to leakage of HC within the cylinder and mixing with oil, thereby diluting the oil. AL engine has oil change interval is same as BS4, which adds true value to the customer. HC dosing leads to less oil dilution, hence longer oil change interval as compared to post-injection, thus providing an advantage over the competition as well as better savings in TCO. Exhaust after treatment system working. T3 and T4 both monitor the temperature of gases entering SCR to ensure the temperature is above 250 degrees. AdBlue is sprayed here so that the exhaust gas and the AdBlue solution mix well before entering the SCR. AL uses air-assisted AdBlue doser to avoid crystallization and deposits. Decomposition retractive tube DRT. This is the long tube between DPF and SCR where the urea gets dosed through the AdBlue doser and mixed with exhaust gases. SCR is coated with copper zeolite, leading to catalytic conversion, which converts the NOx into NH3 ammonia. In SCR, ammonia reacts with NOx and converts it into N2 and H2O. Since SCR is not 100% efficient, some ammonia will be left to the atmosphere, and hence ammonia slip catalyst ASC is required. This is an oxidation catalyst and converts ammonia into N2 and H2O. ASC converts NH3 into N2 and H2O. T5 measures the temperature of gases coming out of ASC. NOx sensor N2 measures the final NOx level coming out of the exhaust. Intake throttle valve ITV. Now, let's discuss the other components responsible for its efficient functioning, such as ITV, HC doser, etc. The major purpose of ITV is to maintain the SCR temperature. While it gets actuated to bring the desired temperature at SCR, it may also get actuated at the starting so that the light off temperatures in EATs can be attained faster. For DOC to function, a minimum temperature of 180 degrees to 200 degrees Celsius exhaust gas temperature is required. But during certain driving cycles of vehicle, this exhaust temperature may not be available. Hence, ITV is used for increasing the exhaust gas temperature, that is, for thermal management. The ITV is in the form of butterfly shape, and its location is in the intake manifold, which will always be in open position and partially closes when required. When ITV closes partially, the air-fuel mixture becomes lean to rich. Hence, more HC in fuel, due to which more unburnt HC are generated, which gets burnt in the exhaust passage, generating higher temperature. The ITV will not work continuously during engine operation. This will work only during lower exhaust gas temperatures. Exhaust after treatment system, emission reduction. Emission gases gradually get controlled one by one when they pass through various stages of exhaust after treatment system. This emission entering the exhaust after treatment system is high as it passes through the EATS components. The emission gets reduced and finally after ASCE, the emission reaches BS6 standards. Exhaust after treatment system configuration. The EATS configuration is of two types: switchback in MDV and inline in ICV. The difference between switchback and inline types of EATS is only the construction. In switchback, we have an additional sensor because of the longer DRT, decomposition retractive tube, where there will be a chance of decrease in temperature. Hence, to check the temperature before SCR and after DPF, we have two sensors in a switchback, whereas in inline, we have only one sensor due to compact design. Mid-NOx strategy. Mid-NOx strategy aids in better NOx conversion efficiencies compared to the competition in lower temperature applications like city bus and tipper. And same is applicable for haulage trucks. Sales tip: Ashok Leyland retains its successful IEGR, which met BS4 emission standards with ease and added it to SER system Mid-NOx strategy. Mid-NOx strategy is the best trade-off to ensure engine and EATS durability and better cost of ownership. Following are the 5 key advantages of AL Mid-NOx strategy over the competition: compact design, low AdBlue consumption, cost-effective, durability, better TCO. Ashok Leyland's exhaust after treatment system adds true value to the customer. Ramesh, who has 5 trucks and 4 tippers, walked into Ashok Leyland's outlet for upgrading his trucks, which he had purchased 10 years back. Ashwin, the sales manager, addresses Ramesh and explains to him about BS6 in detail.
Hello, sir.
Hello.
May I help you, sir?
Yes, I heard about BS6. Can you explain about it?
Let me quickly take you through the benefits of Ashok Leyland BS6 engine. Ashok Leyland uses a unique mid-NOx strategy using IEGR plus DPF plus SCR, where we have retained all the benefits of proven and dependable IEGR engine. At engine level, we have kept it simple and not made many changes.
Does your engine control emission?
Because of a proven IEGR engine and mid-NOx strategy, part of the emission is controlled within the engine itself. Hence, the load on EATS to control emission will be very less. Due to this, our EATS system is much compact and cost-effective, thus leading to incremental payload and low maintenance. Unlike competition, where emission control is entirely dependent on EATS, hence their systems are bulky and expensive. Mid-NOx strategy is the best trade-off to ensure engine and EATS durability and efficiency over time.
What about total cost of ownership?
Coming to the total cost ownership TCO part, Ashok Leyland has low AdBlue consumption compared to the competition, which will help in saving of approximately Rs 2.5 lakh over a period of 5 years. Also, due to the longer oil change interval of 80,000 kilometers compared to 60,000 kilometers of competition, Ashok Leyland will have additional saving in TCO. Ashok Leyland EATS system requires DPF ash cleaning only once in 3.2 lakh kilometers, while competition requires DPF ash cleaning every 2 to 2.5 lakh kilometer. Hence, an additional cost. Also, the time interval for active regeneration in Ashok Leyland vehicle is high, while competition requires active regeneration more frequently. Hence, saving in cost and time. Altogether, this will lead to a low cost of operation per ton kilometer.
What are the other features you offer?
Ashok Leyland also offers unique features like HC Doser, which is offered by Ashok Leyland. Benefits of HC Doser compared to post-injection are less HC slip, hence less oil dilution. Less oil dilution gives a better oil change period. Ashok Leyland also comes with patented air-assisted AdBlue doser, which ensures better mixing of AdBlue and exhaust gas, leading to better efficiency.
Do's and don'ts. Do's: ensure always to use AL recommended AdBlue solution as per ISO 22241 Gulf DEF OS 32. BS6 fuel only to be used and nothing should be mixed with diesel, else otherwise warranty will become null and void. Ashok Leyland's recommended engine oil APIC4 10W30 to be used for all BS6 vehicles for an oil change and oil top-up. Always check AdBlue level through the AdBlue level indicator on the dashboard. When NOx error lamp solid on in instrument cluster, contact nearest Ashok Leyland service center. NOx error blinks when incredibly low or empty quantity of AdBlue needs to fill AdBlue. In case active regeneration is activated in busy or unsuitable area, press inhibit switch. Ensure that inhibit switch to off position as soon as you clear the busy or enter the suitable area for regeneration. When DPF lamp flashing plus stop lamp on plus MIL on, stationary regen not possible, contact nearest Ashok Leyland's service center. To initiate stationary regeneration, press stationary regen switch. Before initiating parked or stationary regeneration, ensure the following. Gear is in a neutral position. Parking brake is on. Wheel chokes are placed on at least one tire in front and rear. AC to be turned off. Exhaust gas outlet is not directed at heat-sensitive objects or zones. Fire extinguisher is nearby. Disconnect PTO devices before starting manual regeneration. Driver to be always present near the vehicle during the park regeneration process. Don'ts: do not press inhibit switch unless required because it will generate more soot in DPF. Do not run the vehicle for a long time under inhibit conditions. Do not crank and keep the engine idle for a long time. Do not press the accelerator, clutch pedal or turn off the ignition during stationary regeneration, which will abort regeneration.